today we're covering 2.5. This is a sincere reminder to remember these four principles or postulates. Alternate interior, AIA, or alternate exterior, AEA, or consecutive interior, CIA, that's the one like the government, it's the one that's different, and corresponding angles. Don't forget those ones. In 2.5 we're going to be discussing specifically parallel lines. Before we talked about just any two lines that were cut by a transversal. Now we're looking at specifically parallel lines that are cut by a transversal. And we're taking the information from yesterday and building on it. So here we have two lines. Now I like to help kids remember this, but I like to use multicolored lines. Oh, the stylus is giving me issues again. I thought we had that. Oh, jeez. So if I code using blue, alright, the blue lines are the two that are being cut by the red line. So the red line is the transversal. And when I look at just those lines, I see the 1 and 2 are corresponding angles. Now what's interesting about when they become parallel, corresponding angles are congruent. That's the new bit of information. Before we just talked about corresponding angles as far as their position on the transversal, but now we know that when they're parallel, they are congruent. I'm trying to go fast and I have a lot to cover. So here, if measured angle, just look at the diagram. Just focus first on the diagram, okay? I see 82. Well, 82 slide up into angle 1. So I know that measured angle 1 equals 82 because they're corresponding angles. I can slide them. Second class power, they slide into the same position. Now, also I noticed that 1 and 2 are a linear pair. So since 1 plus 2 equals 180, I can then use substitution. Instead of having measured angle 1, I can replace it with 82. And then I can subtract 82 over using the subtraction property of equality, and there's my two-column proof for why the measure of angle 2 equals 90 degrees. So here, again, focus on the diagram, right there. I look at 70, and I look at this angle. They are corresponding angles, so I know that they are congruent. So I set them equal to each other because of corresponding angles, and then I add the 14 over using the addition property of equality. I divide by 3 with the division property of equality, and I end up with 28 equals x equals 28. Okay? All I used was the fact that these two angles are congruent. And when I know they're congruent, I can put them equal to each other. Alright, now AIAs. Remember, I like to use colored lines. I draw these on my test all the time. And then I do a red one, I do multicolored pens when I'm doing a test. Because I need to see the blue lines and the red line. And if I can't see that red line's terrible. If I can't see that, then I'm not going to be able to visualize. Seeing the blue lines cut by the red line, I can see that angle 3 and 4 are alternate interior. They're on opposite sides of the transversal from each other, and they're in between the lines. Alternate interior angles are also congruent, which means I can set them equal to each other. Okay? If I look here in this example, again, focus on the diagram. Start with the diagram. I can look here and I could do this. I could say, look, 90 and x, we don't know anything special about those yet. But I can look at 90 and y and say, look at that, they're alternate. They're on opposite sides of the transversal, and they're on the interior. Okay? So I say that y equals 90 degrees because of AIA. I say that x and y add to 180 because they're a linear pair. And then I use substitution and say y equals 90. So I just replace it. I'm going to subtract 90 over using the subtraction property of equality. There's my proof. X equals 90 because of the property of the list of reasons, my list of properties. Okay. Consecutive interior angles. These are the CIA. They're on the same side and they are interior. Okay. CIA, consecutive interior angle. I also call them same side interior if it helps you remember that. What we even know special about this is that they are, they are supplementary. They add to 180 degrees. Okay? Angle 5 plus angle 6 equals 180. If I see the CIA situation, they're on the same side and they're on the interior, I know that they add to 180. So here's an example of this. Oh look, here's the diagram. I don't know what W is. I know that those add to 180, but I don't know what W is yet. So if I look here at 94 and W, there's a special angle pair going on there. Okay? I say W equals 94 because they're vertical angles. I then use the concept of consecutive interior angles right here. They're interior and they're on the same side. Set them added to equal 180. So here's W, and then here's the other angle right here. I add both of those together to make 180. I then use substitution to take this 94 and plug it in for the W to result in this, right? That's what it results to look like. Alright, so I've got my substitution. Now I just combine my terms. This is just algebra. I subtract 89 over. Using the subtraction property, I divide by 13 to get 7. And I hope you guys are good at your algebra, because there's going to be some extra credit questions on the test. So, good luck. Notice an alternate exterior. Again, they're on the outside. Oh, geez. Keep touching stuff. But again, for me, I always draw my blue line, and I draw my red line. I can see that this one is on this side of the transversal, and this one's on the opposite side. Alternate, and on the outside, for their exterior, alternate exterior angles. What we need to know about these is they are congruent. 7 is equal to 8. This will help you when you're given a problem like this. I'm going to draw it for you. I've got my blue lines, I've got my red line. This is on this side, they're on opposite sides, and they're on the exterior of the parallel lines. So I know that they are alternate exterior angles. I put BAM. They are congruent, they're equal to each other. And then I divide by 5 using the division property, and there's my proof. Y equals 23. No ifs, ands, or buts about it. Here's another example. Okay, I've got a double situation going on here. Why is y equal to 80? Okay, I see y at 80 there. But what's my reason for it? I draw my blue lines, and I draw my red line. I can see that they're on opposite sides of the red line, and they're outside of the blue lines, which means that they are alternate exterior angles. And then I say, alright, now why is x plus 80 equal 180 degrees? Why is that true? Well, they form a linear pair. And then I can use subtraction property of equality, and I can say x equals 100. I've solved for both of those problems. Right there, it says, because the original question was find the values of x and y. Alright, next concept. This is a great little book. You can pause and read it if you want to. Right here, this is off of your cheat sheet. You're not going to have your personal cheat sheet on there, but what's going to help you remember this is these top three right here, those are equal, they're congruent, all three of them. CAs, AIAs, and AEAs are all congruent. Now remember how to the CIA, they're the government, they're different. Yeah, CIAs are supplementary. Okay. When two lines are parallel, what four conclusions can you make? So we got two lines are parallel. What conclusions can you make? You've got that corresponding angles, those are equal to each other, and then you've also got that this is supplementary. Write those down in your own words, right here. 2.35, in the statement on the left. Oh, let's see, the statement on the left is the line from the proof. Based on the diagram, what is the reason? Ooh, I like this. Alright, here's the statement. Angle 3 and angle 7 are congruent. Why? Corresponding angles. See how they match up to each other? Now watch this. This might help on the test. We're looking at the two blue lines, and then we're looking at the red line. The lines are going to get more and more complicated, so you need to be able to draw those every time if you get confused. Angle 5 is supplementary to angle 8. Well, let's see here. If I draw my blue lines, and my red lines, sorry, the lines are crazy, I can see that 5 and 8, they're on the inside, and they're on the same side. So I've got inside, same side. I'm going to say consecutive interior angles. Right there. Next one, 4 and 6, vertical angles. That one should be just ingrained in your brain. If you see the x and the opposite of each other, vertical angles. A is perpendicular to K. How do I know that line A is perpendicular to K? I know it's perpendicular to J. Uh-oh, look what I just did. I did two lines and they're perpendicular. That means that I've got they're parallel, sorry. They've got corresponding angles, which means that this angle here is also 90. So I just used corresponding angles to prove that it's 90 degrees. Look at that, that's amazing. Alright, 1 and 2. 1 and 2, same concept. I've got my line here and here, and this is my transversal. They are corresponding angles. Uh-oh. Oh, geez, what do I do? Alright, Control Z, Z, there it is, okay. Got rid of those lines for you. There's 1 and 2 there corresponding. Hopefully you can just start seeing these. 6 and 7. Same side, inside. We call those same side interior or consecutive interior. There it is, consecutive interior angles. 5 and 7, okay. They're on opposite sides and they're inside. So we create alternate interior angles. They are congruent, alright. 6 and 8, same concept, alternate interior angles. Now this is instructions for how to make what I would call flashcards or study guides. These are your instructions. I'm going to go slow one at a time, but I'm going to expect you to pause if you want to make these yourself. So you draw a straight line, then you draw a parallel line. This, I would do these ones in blue, and then do this one in red because that's how I always draw it, is the transversal is always red. But whatever you've got available to you. Then you write transversal and interior and exterior on the first page. That will help you remember. Interior is between, exterior is outside. Transversal is the ribbon cutting across. Label your numbers. This is good for quizzing yourself. If you have just this page alone, quiz yourself on it. Alright, on the point page, same shape is drawn, but now we're going to do corresponding angles. Okay? This is talking about the converse. Notice how this is the converse. That means we've switched it. If I have this set up, and these two angles are congruent, then guess what? These two lines have to be parallel. Usually I give you parallel and ask you to prove angles. Here I'm giving you angles and asking you to prove that two lines are parallel. The converse. So again, if I give you these two angles and they're equal, you can tell me that those two lines are parallel. And here, converse. If those two add up to 180, then the two lines are parallel. Okay, I'm asking you to prove two lines are parallel using, again, pause if you need to. On the last page, it looks like we're going to do two lines are parallel, and then the third one's parallel to it, then I can say that all three lines are parallel to each other. So if A is parallel to B, and if B is parallel to C, then A is parallel to C. That kind of looks like the transitive property to me. Call me crazy. On the blue page, we're going to do this and this. If they're both perpendicular, then they're parallel. That's your little quiz study guide right there, okay? Alright, there's your summary for 2.5. It has been a delight teaching you. I hope this was long enough. I hope you guys were able to get a basic concept. I keep it short so you guys can watch it a couple times, pause, rewind, but if you're absent, here's your chance to learn about section 2.5 and fill in your notes and do your homework.